This week in open source AI was wild. We've got a tool that turns a single image into multi-person talking scenes, a real-time streaming avatar that runs for nearly an hour, nano-banana level video editors for clips, and reasoning-based video edits. Let's get right in. First up, we have AnyTalker, a brand new multi-person talking video generator that can take a single image and multiple audio tracks and turn them into really convincing multi-speaker lip-synced videos. It basically does multi-person talking head generation with natural gestures and interactions, and it even generalizes nicely to non-human characters and stylized art. Let's walk through what it actually looks like in practice. In the simplest two-person examples, you just give it one image and an audio file with two speakers, and the model figures out who should be talking when.
Happy anniversary to ourselves, I guess.
Today is our second wedding anniversary.
The lip sync on both people looks surprisingly accurate, and what really sells it is the subtle upper body movement and timing. They don't just move their mouths, their heads and bodies react in a way that feels live action instead of robotic. Then there's a singing example. You feed it a single starting frame plus a duet track where each singer has different lyrics, and the model keeps both characters in sync with their own parts.
She's giving it to you just right.
I overdosed, should've known the game. Now I can't get you out.
The expressions and timing look strong overall. The only noticeable issue is that the singer on the left never really opens his eyes, and the right singer opens them at the start and then also drifts into a mostly closed-eye look. It still feels surprisingly good for a first public release, but you can tell eye behavior is one area that can improve. When you push it to 3 speakers, it actually holds up really well.
With our product, we have got your back.
No matter where life takes you, trust in quality that lasts.
For us, it's all about staying connected and making life easier.
You get 3 people in one frame, each with separate dialogue, and they all take turns talking with decent lip sync and small body motions that match who has the floor at that moment. It feels like a real conversation instead of 3 puppets moving in sync. Once you go to 4 people in a single frame, some of the AI cracks start to show.
I can't believe how fast this year went by. What's everyone's plan for next Christmas?
I think I want to spend it with family again.
Maybe something outdoors, like a snowy hike.
I love the idea of starting something new for next year.
You still get okay lip sync, but the eyes in particular start giving off that synthetic vibe, and you can tell something is off even if you don't know it's AI. So for now, 3-person scenes feel like the sweet spot, and 4-person might work better if you frame it differently or don't put everyone front and center. Where it gets really fun is in stylized and non-human cases.
You think it's time to move on? The kettle won't wait much longer.
Maybe, but there's something I gotta settle first before we ride out.
In a 2-person art style example, the lip movements and body motion stay strong even though the characters look like illustrations instead of real humans. So if you're into anime or painterly looks, this model can still keep everything synced.
The suspect must be using a side gate.
I'll check the gate logs while you two follow the alley cameras.
I'll triangulate timestamps from the cafe CCTV.
In a Ghibli-style 3-person shot, you not only get decent lip sync and character motion, but also a bit of camera movement, which makes the whole thing feel more like a directed scene rather than a static talking head render. And it's not limited to humans either.
嫌疑人一定是从侧门逃走的。
我去查看门禁记录，你们2个去调小巷的监控。我来比对咖啡馆监控的时间戳。
In a 3-dog example with Chinese audio, each dog has its own voice track and takes turns speaking, and all 3 stay roughly in sync with their lines. So overall, across real people, stylized art, and even animals, the model stays surprisingly consistent on timing and lip sync, especially up to 3 subjects. Under the hood, AnyTalker is built on top of a large WAN video diffusion transformer, and the key innovation is a module called Audio Face Cross Attention that lets the model scale to any number of identities. It encodes video as 3D VAE tokens, text with a T5 encoder, the reference image with clip, and audio with wave to Vec2, then repeatedly runs a special attention block once per face plus audio pair, so each person's audio only drives their own region in the frame. A learned face mask constrains where each speaker is allowed to move, and they also use a custom temporal mask, so each video token only attends to a local window of audio, which helps keep long clips in sync without drifting. To prove it actually works for multi-person interaction and not just single faces, they introduce a new benchmark called interactive eyes, plus a custom interactivity metric that looks at how much the eye region moves during listening periods. On this benchmark, the 14B AnyTalker model scores about 1.01 on their interactivity metric versus around 0.45 to 0.49 for previous multi-person methods like bind your avatar and multi-talk. And it also achieves a lower FVD, around 424, than those baselines, meaning better perceived video quality. Even the smaller 1.3B version already beats prior methods on interactivity, which lines up well with the more natural idle behavior you see when characters are not speaking. In terms of availability, the code and checkpoints are released under an open license, and they provide an interface, inference scripts, benchmarks, and a Gradio demo so you can try it without wiring everything yourself. Right now, the smaller AnyTalker 1.3B model and the first stage assets are available, while the bigger 14B Pro model is marked as coming soon, so the fully scaled version is not yet downloadable. They don't publish exact VRAM numbers for local inference, but you should expect to need a serious GPU setup if you want to run it locally. As always, all relevant links will be in the description so you can explore more examples and experiment yourself. Next up, we've got Live Avatar. This one is also a lip sync tool, but the big deal here is that it's built for real-time streaming and truly infinite-length avatar generation. It's powered by a 14 billion parameter diffusion model, and the whole framework is designed so you can drive an avatar for minutes or even hours without the usual identity drift or weird artifacts creeping in over time. To give you a feel for what it can do, there's a live stream style demo where on the left you see the real person on camera, and on the right you see an avatar driven only by the audio in real time.
魔鬼烟火上空滑翔伞直播呢，这可是海拔2800米的魔鬼温差层，紫外线强到能晒脱皮。赶紧点击小黄车，我的高海拔海洋防晒霜 SPF 90加航天级防护，专治各种高原暴晒。
反差效这么厉害啊！
那必须的。 这可是拉萨同款防晒霜，专为极限环境研发。
The avatar tracks the voice surprisingly well. The mouth shapes, timing, and basic facial motion feel natural enough that if you weren't looking for flaws, you could easily accept it as a real webcam feed running through a virtual camera. There are demos in both Chinese and English, and in each case, it's the same idea. Real person on one side, and the right-hand avatar stays locked in with the speech as it happens.
What's going on?
The scaling law is a computationally obscene cult. It promises AGI, but delivers only bloated, expensive stochastic parrots. The end of the scaling law era is my divine, immediate revelation.
I heard you have a new plan?
Yes, I have a new plan. We must abandon the worship of scale. Focus on efficiency. Focus on genuine architectural intelligence.
The really crazy part is the long-form example. They show a video that's roughly 50 minutes long where the model was given a single portrait and a long audio track. At the start, the lip sync and identity look clean, which you'd expect.
All that lingers in your heart. I used to think that wisdom came from knowing more, but as I've aged, I've realized it comes from listening. More, listening to silence, to nature. To people who speak softly, not loudly, I recall once during...
But what matters is what happens at the 25-26 minute mark.
Times presence is enough. People often ask me, what advice would you give to the young? And I always hesitate because what worked for me may not work for them. But if I were to offer one thing, it would be this. Value stillness. Find moments each day, no matter how brief, when you are simply present, not thinking...
And then again near the 47-48 minute mark.
It's like tiny diamonds. Each step was deliberate. A sort of communion with the earth. We were not in a rush then. Time moved with the sun, not with the clock now. I see young people rushing from one place to another, their eyes glued to devices that promise connection.
And the model is still holding everything together. Across the entire duration, the face doesn't slowly morph into a different person, the colors don't drift, and you don't start seeing the usual glitches you get from other lip sync tools that weren't designed for long runs. The whole point of showing start, middle, and end like that is to prove that this system is actually stable for long, continuous content, not just short clips. And it's not limited to just one realistic talking head either. There are portrait-style examples that look like a normal offline lip sync pipeline.
You must treat them like children. You learn when they are thirsty and when they need the sun. Look at this orchid. It is in a very good mood today.
Plus a kid in a classroom and various art or cartoon styles, all being driven by audio in a way that still looks coherent.
It's so strong it traps moons like a cosmic magnet. And Earth's tilt causes seasons, just like a spinning top.
part of baking is watching the dough rise in the oven, and the whole house fills with that warm. To understand the whispers of birds. The price, well, for a friendly face like yours, I'll give you a special deal.
Under the hood, Live Avatar is a pretty serious piece of engineering. It combines a large WAN-style video diffusion backbone with a causal few-step student distilled from a slower teacher using something they call self-forcing distribution matching. That distillation step basically compresses the long diffusion trajectory into just a few denoising steps while keeping visual quality high. And they also inject noise into the historical key value cache during training, so the model learns to stay stable even when small errors accumulate over long sequences. For real-time performance, they introduce a system trick called time-step forcing pipeline parallelism, where each GPU is assigned a fixed diffusion step and only ever runs that specific step. Instead of one device doing all the diffusion steps in sequence, you get a spatial pipeline. As soon as one GPU finishes its step, it passes the latent to the next one, and everything runs in parallel once the pipeline is full. With this setup, their distilled 14B model can hit around 20 frames per second end-to-end on 5 H100 GPUs with a 4-step sampler, which is fast enough for practical real-time streaming while still using a big, high-fidelity model. To solve the long horizon stability problem, they add what they call the rolling sync frame mechanism. In simple terms, the system keeps a reference sync frame in the model's memory and periodically aligns the generation back to that canonical appearance while also adjusting the positional encoding or ROPE so that even as time goes on, the model still sees that reference frame in a consistent relative position. Combined with their key value cache strategy, they can generate videos far beyond the length seen in training. In stress tests, they auto-regressively roll out up to 10,000 seconds of talking head video without the identity or color drifting in a noticeable way. In terms of availability, they've already released the real-time inference code plus the model weights so you can run the same 14B avatar model they use in the paper. For full real-time streaming at around 20 FPS, you should expect to need a serious multi-GPU setup similar to their reference configuration of 5 H800s. For offline or lower FPS usage, you might be able to get away with a single GPU once their single GPU inference path is fully polished. According to their roadmap, UI integration for easy streaming, better single GPU offline generation support, multi-character features, training code, TTS integration, and Live Avatar v1.1 are still on the way, but the current release is already enough for you to download, install, and start experimenting. All the links will be in the description. Next up is EgoEdit, a brand new video editing model from Snapchat that's designed specifically for egocentric first-person videos and real-time AR-style edits. Instead of just generating a whole new video, this one takes your original POV footage and surgically edits objects, materials, or styles while keeping your hands, camera motion, and environment consistent, so it feels like you're actually modifying what your camera sees in real life. To get a sense of what that looks like, imagine a shot where your hand is picking up a handbag. In the edited version, the same hand, same motion, same background, but now it's grabbing a violin instead of the bag. Another clip has a hand under a water dispenser. After editing, it's lava pouring out instead of water, but the arm pose, the dispenser, and the scene all stay locked in. In another example, an apple sitting by a keyboard on a desk is seamlessly turned into a rabbit, and a person holding a pillow suddenly appears to be catching a basketball in exactly the same pose. It also handles more semantic edits nicely. A red stop sign in traffic becomes a green go sign with the shape and color changed. A woman walking a bicycle is swapped out for a fairy-like AI character while the street and camera path remain the same, and two snowboarders on snow get replaced by two robots doing the same action. They even show a boring ceiling shot turned into a scene with a dragon flying across and breathing fire that actually ignites parts of the scene, a woman in a kitchen sprouting white wings, a green car recolored to red, and a camera moving up a staircase where a dog is now present on the steps. They also directly compare EgoEdit visually to LucyEdit. Same input video on the left, EgoEdit's edited result in the middle, and LucyEdit's result on the right. In those side-by-sides, EgoEdit's outputs look much closer to the original video in terms of structure and temporal consistency, while still following the text instruction more faithfully, whereas LucyEdit often looks less aligned or less stable over time. This lines up with the paper's benchmarks. On their egocentric EgoEdit bench, EgoEdit reaches a VLM quality score of about 7.76 versus roughly 5.44 for LucyEdit and 5.24 for Inst-V2V, with better text alignment and temporal consistency as well. There's also a streaming variant called EgoEdit RT, which runs in real time. It scores very close to the full offline model on the same benchmark, so you're not giving up much quality to get live performance. Under the hood, EgoEdit is built on top of a large WAN-style text-to-video diffusion transformer that's retrained for editing using a carefully curated dataset called EgoEdit data. EgoEdit data contains about 49.7K unique egocentric videos and 99.7K instruction edit pairs, heavily focused on hand-object interactions like picking things up, holding items, or manipulating tools, with both this object replace and remove or add this object style edits. The model conditions on both the noised target video and the original source video using channel-wise concatenation instead of concatenating token sequences, which keeps the transformer sequence length manageable and is a big part of why they can still run it in real time. In terms of availability, Snap's team has marked the repo as final review completed, but the actual code and full model release are labeled as code release, TBD, or soon, along with planned releases of EgoEdit data and EgoEdit bench. For now, this is more of a coming soon research drop, but as soon as Snapchat releases the code, dataset, and benchmark, all the links will be in the description so you can dive in. Next up is a super interesting one, unified video editing with temporal reasoner or VideoCoF, which is basically like NanoNana but for video instead of images. Think of it as a reasoning-aware video editor that can understand detailed text instructions, figure out exactly which region or which person you mean, and then edit only that part of the video while keeping the rest perfectly intact. The examples are wild. In one clip, you have a woman in a brown dress, and in the outputs, the model turns that into her wearing a red leather coat in one version and in a completely different outfit in another, while the background and motion stay the same. In a kitchen scene, the model takes pale dough on a table and turns it into brown bread just by changing the material or appearance of the dough area and leaving the rest of the shot untouched. In another video with 4 credit or debit cards on a table, the model removes exactly one specific card in the edited version. And in a 3-person standing shot, it erases one of the people so that only 2 remain with no obvious in-painting artifacts. It can do object removal on more complex stuff too, for example, removing a monitor from a desk or deleting a specific character from a crowd while keeping lighting and motion consistent across frames. And then you have the reasoning-style prompts, like in a classroom scene where the instruction is remove the girl with dark skin wearing a blue cardigan on the right in the background. The model identifies exactly that student and removes only her, while every other student, the teacher, and the desks remain untouched, which really shows off the temporal reasoning and instance-level understanding. It's not just about removing things. It can add and transform content as well. In one video, a person is working with plants, and the prompt is to add a white Samoyed dog. So the dog appears in the edited video in a plausible position and lighting, integrated into the scene instead of looking pasted on. In another, a woman stands holding a balloon and pointing at it. The instruction is to add another woman on the left, and the model cleanly inserts a second character beside her while preserving the original. There's also a sea or lake shot with subtle camera motion where the prompt is to add a yacht with flags, and the yacht appears in the water following the camera's motion, so it feels like it was always there. It handles local attribute edits nicely too. 3 women standing together with only the middle woman's top changed to red, white jeans turned into blue jeans, and a cooked crab in a container converted into a live, uncooked crab that looks fresh rather than boiled. On top of that, there are plenty of style transfer and color change examples that show it can do both local semantic edits and more global stylistic tweaks while keeping the video temporally stable. Under the hood, VideoCoF is built on a WAN 14B video diffusion transformer and introduces a chain of frames, or COF idea, that forces the model to follow a see-reason-edit pipeline. Rather than just concatenating source and target tokens temporally like older in-context methods, it explicitly inserts a reasoning stage where the model predicts special reasoning tokens that act like a soft, gray attention mask indicating the edit should happen, and only after that does it generate the edited video tokens. All three streams, the source video, the reasoning frames, and the edited video, are encoded separately by a video VAE and then concatenated along the temporal axis, so self-attention can use both the clean source tokens and the reasoning tokens to localize the edit region before synthesizing the final frames. On benchmarks, VideoCoF does really well, especially considering how little data it uses. On VideoCoF Bench, which covers 200 videos and 4 tasks, object removal, object addition, object swap, and local style transfer, with many multi-instance and left-right disambiguation prompts, it gets the highest instruction following score and success ratio across all tasks when judged by GPT-4o as a VLM, while still keeping strong perceptual quality. For example, averaged over the benchmark, VideoCoF reaches an instruction following score of about 8.97 and a success ratio of around 76%, while a strong in-context baseline, ICVE, trained on 1 million pre-training pairs plus 150K fine-tuning pairs, only reaches about 7.79 and 58% success, and LucyEdit lags further behind. Clip.t text video alignment scores are also highest for VideoCoF, indicating better semantic alignment between the prompt and the edited video. And Clip.dino consistency metrics show it keeps structure and temporal coherence competitive to or better than other methods. In terms of availability, the authors have released the code, the VideoCoF 50K weights, and the curated dataset via their GitHub repo, and they also provide model weights on Hugging Face for easier integration. The base model is a WAN 14B video diffusion transformer, so they don't claim this as a runs on any laptop tool. You should plan on a high-end GPU with plenty of VRAM if you want to reproduce their results locally, and multi-frame editing at higher resolutions will be more comfortable on data center class cards. The good news is that the inference code is already out, so you can start experimenting with object addition, removal, local style edits, and reasoning-based instance selection right away, and all the links to the project page, paper, GitHub, and Hugging Face models will be in the description for you to explore. All right, that's it for today's lineup of insane open-source AI video tools. If you found even one new idea you want to try, do hit like and drop a comment telling which tool you're most excited about using in your workflow. I'll see you in the next one.